Happy Wednesday, everyone. My name is Yilin Zhuang. I'm the Water Resources Regional Specialized Agent in University of Florida IFAS Extension. Welcome to the Water Wednesdays. Water Wednesdays is a Facebook Live series about Florida's precious resource, water. Every Wednesday afternoon at 2 o'clock Eastern Time, we'll live stream a 30-minute talk about Florida's water and what we can do to protect it. You don't need to register. Just follow us on Facebook and tune in every Wednesday afternoon at 2 o'clock to watch the live streaming and interact with our guest speakers. This month, we'll focus on microplastics. Last two Water Wednesdays, I went through what microplastics are and what we can do to reduce plastic use. I will post the links to the recordings in the comment section. You can catch up if you missed the live sessions. As an alternative to traditional plastic use, we're hearing the term bioplastic more and more often. So what are bioplastics? Are they better than traditional plastic? With these questions, let me introduce today's guest speaker, Dr. Maya McGrath. She is the Associate Program Leader for Marine and Coastal Education and Florida Sea Grant Associate Director for Extension and Education. She is also the founder of the Florida Microplastics Awareness Project. So are microplastic better? Let's welcome Dr. Maya McGrath to tell us the story. Thank you, Dr. Maya.
All right, thank you, Yilin, for that welcome. So as Yilin said, today we're going to be talking about bioplastics and primarily addressing the question whether or not they are better than petroleum-based plastic. And let me turn on my captioning. We are doing this presentation this month in September because every year we try and promote the month of September as Microplastic Awareness Month. As Yilin told you, I started something called the Florida Microplastic Awareness Project, and we attempt to get people to reduce the amount of plastic waste that they generate in hopes of reducing the microplastics problem in our water and waterways. So I need to start by answering the question, what are plastics? I will give you the caveat that I am not a chemist, but I have talked to several chemists, and the simplest answer for what plastics are is that they are chains of similar molecules or identical molecules that are linked together. So you may have noticed that a lot of different plastic resins have names that start with poly. We have polyethylene, polyester, and so on. This is because the second part of the name is the chemical compound that is repeated many times, which is the poly. Okay. When we think about plastics, all of those words that may come to mind are typically made from petroleum. So when we see the different, what we think of as recycle numbers on plastic products, these are actually resin codes, which just tell us what particular type of plastic the product is made from. It doesn't actually have anything to do with the recyclability of that product. So just keep that in mind. So that was plastic. What about bioplastic? Now this is where we don't really have a single good answer. There is a lot of inconsistency in the use of the word bioplastic and different variants on that word. So you may hear products described as being bio-based plastic, bio-derived plastic, biopolymer. Sometimes plastic will be called biodegradable, And sometimes it will be labeled as compostable. But what do all of those things actually mean? Well, this is where we have a bit of a challenge because there is no regulatory standard for using any of these terms. So pretty much you could put the phrase biodegradable on anything you want and market it as being biodegradable without that really meaning a thing. So most of us, when we think about the term biodegradable, we're assuming that it means that it will decompose when it's given some oxygen, probably some water, and some microbes, some bacteria or fungi or other things. And as it decomposes, it will produce those harmless elements that make up the product in the first place. They are often things like carbon dioxide or water. So now we run into the challenge because if you think about it, anything that is made out of organic material, right, anything that's carbon based, will eventually biodegrade. So our question is, what time frame are we comfortable with in using the term biodegradable? Are we comfortable with it maybe taking thousands of years or tens of thousands of years to go through that process? Typically, we're not. So, what affects how quickly things will biodegrade is really the environment that those materials are in. You could take something like a piece of newspaper and in a home compost heap where it gets some water, it's got lots of oxygen, there are some bugs and things in there that might help chew it up a bit, it will disappear pretty quickly. But if you take that same piece of newspaper and maybe seal it inside a plastic bag and bury it in a landfill where it does not get exposed to oxygen and water and any of those microbes, it could last for perhaps 100 years or more without any changes. So for something to biodegrade, as I've mentioned, it needs to be exposed to oxygen, moisture, and sometimes quite hot temperatures. The hot temperatures plays a role when we look at plastics that are labeled as being compostable. There is no strict regulation of that term either. However, there are some standards that may be referenced by manufacturers when they make the claim that their product is compostable, their plastic product. So there are a couple of different sets of standards. You may see the letters ASTM. A product may say meets ASTM 6400 or meets ISO and some other series of numbers. These are international standards that have particular criteria that the product must meet in order to say that it is compostable and meets that standard. What's most important for people to understand is that if a plastic says it meets one of those standards, great, it is technically compostable in an industrial or commercial composting facility. This is different from your backyard compost heap, and it is very different from the landfill. Industrial and commercial composting facilities provide quite high heat, moisture, oxygen, and it can take months for these products to compost in that setting. Here in Florida, we do not have industrial or commercial composting facilities that are available to us to use. So the bottom line just because something is made from plants, which a lot of bioplastics are, a lot of them are made from corn or potatoes or other plant-based starches that are then turned into plastic components. Just because it starts off as plants doesn't mean that it will biodegrade quickly or in a non-commercial composting facility. And some will not even compost in those commercial composting facilities. So sometimes plastics that are made from plants are called bio and then given the resin name that is the same as if the product was made from petroleum. So you'll see bio PET. So that means it's PET plastic. Chemically, it's exactly the same as the plastic PET that is made from petroleum. It's just that the feedstock was a plant. Similarly, we have biopolypropylene, biopolyethylene, and what this means is those products are exactly the same as petroleum-based counterparts. They can be recycled like their petroleum-based counterparts if that is an option available in your area. They cannot be composted. So this sometimes causes confusion because people don't know what to do with bioplastics. Now, there's a new group of plastics, relatively new group of plastics, that people are trying really hard to develop at a commercial scale. And these are called PHA plastics, or sometimes PHB. And if you want to know what the long word is, it's there on the slide. But basically, these are plastics that are made from an energy storage product that bacteria produce. So one chemist described to me that this process is literally collecting dust from bacteria and pressing it together to turn it into plastic. So you need a lot of bacteria to generate a lot of dust so that you can make this plastic. Well, why are people trying to use or create PHA plastics? PHA plastics have a lot of the same characteristics as other plastics. A lot of these are desirable. They're thermoplastics, which means they can be molded by using heat. They are stable in ultraviolet light, which is a benefit over some of our petroleum-based plastics and other plastic types. Some of the disadvantages are the color and perhaps the strength. The biggest advantage, though, is that these PHA plastics can be synthesized so that they are biodegradable under different conditions. So you could essentially customize the plastic for the condition that it's likely to end up in and where we want it to decompose. That might be in a landfill where it doesn't have oxygen and it doesn't have moisture. That might be in a swamp where we're using a plant pot and planting marsh grass and we want it to decompose where there isn't much oxygen, but there's lots of water. So you can customize the plastic for all sorts of different conditions. The biggest challenge, though, is getting all of that dust. It's difficult to produce a large enough quantity of PHA plastic at a price that is competitive with petroleum-based plastics or bioplastics. So the biggest difference between all these different kinds of plastics that we use really is the length of time that they will take to biodegrade. And as we've said, we would really like that time to be short, right? Weeks to months. And you can see that in almost all of these cases, it's going to take a lot longer than that for the plastics to decompose, especially if they're out in the environment. I want to just briefly talk about a study that the group Five Gyres did. They have published something that they call the Better Alternatives Now list, or the ban list. They recently, in I believe it was 2018, came out with their 2.0 version of their list. And their question was, there are all these different products out there making all of these claims, but how do they really do in the environment? So they took a number of different kinds of plastics that were labeled in a number of different ways, and they buried them in just a home compost setting and looked at them after 6 months, 12 months, 24 months. And they also put them they submerged them underwater at a saltwater marina. So put them in a crate underneath a dock and left them there for 2 years. And then they took photographs of them. So I have a couple of slides showing you some of their results. The way the slides are set up in the series of images on the left-hand side is what the product looked like to begin with. And then in order, you have buried in land or in soil for 6 months, 12 months, 24 months. And then the right-handmost picture is what the item looked like after 2 years underwater. The top product in this image was a cup that was labeled as being compostable, BPI certified, made from corn. So remember what I said about the certifications requires the product to be composted in an industrial or commercial composting facility. And what you can see is that, yeah, that product was still around 2 years later. In the water, it didn't look a whole lot different than it did to begin with. On land, it's kind of morphed its shape somewhat, but it hasn't turned back into its elemental forms. It's just kind of broken apart. The middle one is a compostable hot cup. So this would be like maybe a coffee cup that you would get at a restaurant as a to-go cup. These are lined often with plastic. In this case, it's lined with a bioplastic, a plant-based plastic, and that helps the paper cup be more durable. Well, it also means that it doesn't all go away. You can kind of tell from this series of images that both on land and in the water setting, some of the paper went away, but you're still left with that plastic that had been lining it. The bottom image is a paper straw, and obviously it did very well under both sets of conditions. And I've got one more to show you. These were bags of different types. The top one is one that says it meets one of those ASTM standards and that it will degrade in a landfill in 18 to 36 months. Well, it did degrade in the home compost setting in 2 years, but that use of the term degrade simply means it broke apart. And you can see that in the ocean setting, it almost looks identical to what it looked like before it went into that setting. The middle set of bags, that type, they just had a label that said environmentally friendly. Well, that's kind of a nothing label because, again, there's no regulatory standard that is met or that needs to be met in order to use that term. And you can see that the bag really didn't change at all in either setting. The third one, though, is a bioplastic bag that meets one of the ASTM standards, and it actually performed better than you would expect it to because it was not exposed to the industrial composting settings, and yet even with as little as 6 months in a home compost setting, it completely disappeared. So the bottom line is that you cannot really tell how a product is going to behave in the environment by reading the claims on its label. And unfortunately, many products that appear that they would decompose and become harmless in a short period of time don't actually do so. So it's worth doing a little bit of research before you spend extra money to purchase something that calls itself bioplastic just because you're hoping it will be more environmentally friendly than petroleum-based plastic. If you'd like to learn more about microplastics or bioplastics, I'd encourage you to visit the Microplastic Awareness Project website. The shortcut to that site is plasticaware.org. If you have specific questions and don't have a chance to ask today, or you're watching a recording of this, my email address is there and you're welcome to reach out to me, mpmcg@ufl.edu. And with that, Elin, if we've had any questions come in, I will be more than happy to answer them.
Thank you so much. That's to me, it was a little surprising to know there are no available commercial biodegradable composting facilities in Florida. Yeah, to me, it's a kind of, I was really surprised. Let me look at my Facebook because I know there are about 10 seconds delay between Facebook and the Zoom because we are using Zoom to broadcast this live streaming. So maybe a little bit delay, you might still be typing your questions. So I don't see a question here, but I do see a comment here. Thank you so much. Very eye-opening. So I will say the same thing. Thank you. And thank you, Maya. It is very eye-opening. I'm looking here. I got a question. It's what are most grocery stores produce bags?
So most grocery store bags are low density polyethylene, which is it'll have the code number 4 on it. They are typically petroleum based. Even the ones that are colored green aren't necessarily any different than the ones that might be brown or clear or white or some other color. I can't speak across the board for every grocery bag or every grocery store's bag. It's something that you'd have to ask at the store. If, again, just because they're colored differently may or may not mean that they are any different. And chances are they are not going to be any more biodegradable. The bags in the produce section won't be any more biodegradable than the bags that the groceries are packaged in at the checkout. So again, it's something you would have to ask the store. There may be stores that are using bags that will be compostable in a home compost heap. If that is the case, you then, in order for them to decompose, you do have to bury them in a home compost heap and not just put them in a trash bag that goes to the landfill.
Thank you. Yeah, I think everyone probably is the same as me now. We're a little bit shocked. So just like you mentioned, some products they labeled environmental friendly, but it doesn't tell anything. It's just no such standard like that. So it's
right.
Bioplastics.
Yeah, so going back to the grocery store question, one thing to think about when you're in the produce section at the grocery store is, do I really need a bag for my produce? I tend to shop at farmers markets and I have my one reusable bag that everything gets put in, but I don't use smaller bags. I will take a container with me for loose items. Like if I'm going to buy green beans, I'll take a container with me and put the beans into that container so they can be weighed. I can take them home in the container. And then when I'm done with the beans, I can wash the container and reuse it for something else. So that's one thing that I do to try and reduce the plastic bags that I end up with. The other thing to know about all of those plastic bags is that you can take them back to many stores for recycling, but you cannot put them in your curbside recycling bin. They are not accepted there. They will gum up the machinery that sorts the curbside recycling. So any plastic that's labeled with a 2 or a 4 and is film, is a bag, can go back to one of those stores and be put into the plastic bag recycling container.
Maya, I have a question here. It's about the trash bags. So will a trash bag made of the bio bags that did compose in the experiment decompose in a landfill?
Not necessarily. So that one bag that disappeared completely after 6 months in the home composting setting, if it was not exposed to oxygen and moisture, I cannot say that it would decompose in the landfill. I also cannot say that it would not decompose in the landfill. It would all depend on the environment that it's exposed to there. So if it's something, when it gets to the landfill, it gets buried immediately, chances are it'll stick around for years. If it happened to stay up close to the surface where it was more likely to get exposed to oxygen and moisture, then it might well decompose in the landfill.
Okay, thank you. And
sorry for depressing everybody.
You can tell from my tone. Yeah, that's yeah. Another, it's more like a comment to what you just said about those produce bags. You carry your container, and Trav said she also carries anything she can. That also reminded me, because what I'm doing is because after your talk about polyesters, because I got those cotton bags, and I use those cotton bags for my groceries, just loose items like apples, sometimes peppers. So that can be another alternative for if you want to reduce plastic use instead of investing, doing research. I mean, it's doing research and then invest on bioplastic bags. Probably you can use these cotton bags.
Right. Yeah, cotton bags are probably the more, I guess, compostable alternative that we have.
Okay. And if you have more questions, please just leave in the comment section. I will read it out and Dr. Maya will answer your questions. While you are typing your questions, I post a link of our evaluation of the Water Wednesday. So we will appreciate if you can take a few minutes to take the survey and tell us how we can improve the Water Wednesday series. And also, if you like our Water Wednesday series, please give us a thumb up, like our video, and share with your friend. Just a little bit spoiler for next week, we'll talk about how microplastics are affecting marine ecosystem. So if you're interested, you want to know the answer, just tune in Wednesday afternoon at 2 o'clock Eastern time. All right, let me go back to the comment section, see if I have any more questions. I think seems like that's it. Everyone is a little bit in shock. So I don't think, the least thing I want to do is to end our Water Wednesday. So with a little bit depressing mode, but that's what I learned from Dr. Maya. It's actually we can all take steps to reduce plastic use. So this month, it's a microplastic awareness month, and Maya is posting a tip basically every day, like what we can do on our daily basis, some simple steps we can reduce plastic use. I will post that link, the Facebook link in the comment section. You can follow the Facebook page and take those simple steps to reduce plastic use. So with that, I will thank you, Maya, again for this informative and eye-opening presentation. And also thank for everyone here for your time, and hope you enjoy the rest of your Wednesdays. Bye now.
Thanks, everyone.